In this module, we are going to be looking at the virtual private cloud service on AWS VPCs. VPCs help customers on AWS to be able to create private networks in the cloud. University or any company that wants to create private network on the cloud, they use the VPC service. Now, what is a network? A network basically is an interconnection of two devices. So if you have a laptop, a printer, a scanner, and all these other devices, and you want these devices to interconnect with each other or communicate with each other, you can do that using what we call a network, a local area network. Now, how do companies provision networks on the cloud? Companies provision networks on the cloud using what we call the virtual private cloud service, the VPC service. And this service gives companies the possibility to logically store their resources within a private network in the cloud. So they're just basically doing a private network in the cloud. Now, as far as the VPC service is concerned, what are the key things which you must understand? You might have an institution having a big network, and that institution wants to partition the network into smaller networks. Let's take this logical example. You might have a university, which is the main network. So you can have here a university, and then we have different faculties. We can have the faculty of law, we can have the faculty of science, we can have the faculty of arts, and the list continues. So all these are subcategories, or all these are smaller organizations inside the main organization, which is the university. Now, as a network engineer or as a solutions architect on AWS cloud, you might want to give all these faculties, maybe resources in the faculty of law are not supposed to have interference with resources in the faculty of science, and they are not supposed to have interference with the faculty of art. So for you to do that, you are logically separating your main network, which is your university network, into smaller networks, which is the faculty network. So as far as VPC is concerned, the university can be the VPC service, and then we can now have faculties, the individual faculties, as subnets. So we can have the faculty of law as a subnet 1. We can have another faculty, faculty of science, as subnet 2. We can have the faculty of art as subnet 3, and so on. Now, for the resources in subnet 1 to communicate with the resources in subnet 2 to communicate with the resources in subnet 3, we have different methods of communication. But each of the subnets have what we call a route table. So each of these subnets have a route table. The routing table tells the VPCs how to route traffic between one subnet and the other, and even how to route traffic out of the network. So route tables will give the VPC knowledge on how they are to route traffic within this subnet. So if I'm to route traffic from subnet 1 to subnet 2, how do I do that? Using route tables. If I'm to route traffic from subnet 2 to subnet 3, how do I do that? Using route tables. So route tables give you the possibility to be able to logically group the way traffic will be routed within your network, and not just within your network, but out of the network. As far as VPCs are concerned, another very important thing which you have at the back of your mind is internet protocols, IPs. IPs basically help you to identify resources. They are like just like digital IDs. So every device you have on the internet, you can logically identify those devices using their IPs. When we talk about IPs in VPCs, you must understand what we call CIDR ranges. Now, CIDRs basically are the ways through which you can take a big network and you group into smaller networks called subnets. For you to understand CIDRs, you take a big network, maybe the university, and then you partition it into faculty of law, you partition it into faculty of science, you break it into faculty of arts, and the list continues. The main university IP address might be 192.100.0.0. Means that every resource that is going to be, and this will be the VPC CIDR, So every resource that is going to be in this network must fall under the 192.100.0.0 IP address range. And for you now to partition all these faculties into smaller subnets, you might now have this VPC constituting what we call subnet 1, and the subnet for faculty of this might be 192.100.0.0/16. This same VPC can have another subnet for faculty of science, which is subnet 2, and this subnet can be 192.100.0/24. And then we can have this same VPC having another subnet, subnet 3, and this subnet might be for the faculty of arts, which can be 192.100.1/32. So all these are the logical partition. So we have the university network, which is 192.100.0.0, which is the VPC CIDR, and then we take this VPC and we partition it into smaller networks or subnets, or into smaller faculties, which we call them as subnets. And we can have subnet 1 for the university, for the faculty of law, which is 192.100.0.0/16. We can also have subnet 2 for 192.100.1.0/24 for the faculty of science, and the list continues. So this is the logical breakdown of the faculties from the VPCs to the subnet. And remember, what enables us to be able to route traffic within this subnet is what we call our route tables. So we must have route tables. The route tables control traffic based on traffic that is getting into the network, which we call the inbound, or traffic that is getting out of the network, which we call the outbound. So you must take note of that as far as route tables are concerned. So you might have a route table, and the route tables help us to logically identify traffic that is coming into our network, which we call inbound traffic, and traffic that is leaving our network, which is called outbound traffic. Now, as far as traffic into and out of the network is concerned, we have key services that you must understand as far as VPC is concerned. We have the internet gateways, which enable us to expose resources in our network to the outside world. So the internet gateway is what will help us to access resources over the internet. And then we also have the NAT gateways, which also gives us access to the internet, but from a private subnet. So as far as VPC is concerned, you should understand what are internet gateways, NAT gateways, and then we also have security groups. Now the security group helps us to control, because we say inbound traffic is traffic getting into the network, and then outbound traffic is traffic leaving the network. Now, which kind of traffic are we allowing into our network? What type of traffic do we allow into the network? What type of traffic do we allow into the network? And what type of traffic do we leave out of the network? All this selection of traffic into and out of the network is done using security groups and network access control lists. When you have traffic into and out of the network and you can control, you can now do that using the security groups and the network access control list. And also, as far as the VPCs is concerned, and for subnets in VPCs, we can have private subnets and public subnets. Now, the private subnets, no access to the internet, no internet access, while the public subnet has full access to the internet. And as far as the public and private subnets are concerned, you must understand two key services. For the public subnet, we have an internet gateway, and then for the private subnet, we have the NAT gateway. So by the end of this module, you should understand VPCs, which is the virtual private cloud. You should understand subnets, which we have the private subnet and the public subnet. You should understand route tables. We should understand internet gateways. We should understand security groups, and then we should understand network access control lists. Also, you want to understand what we call the CIDRs. You can look up CIDRs from the AWS documentation. So by the end of this module, we should understand VPCs, we should understand public subnet, private subnet, route tables, NAT gateway, internet gateway, security group, and network access control list. Let's get into the AWS console and see all these resources from the console. So we are on the AWS console and we are going to be looking at the key AWS services. Now we have the virtual private clouds, like I mentioned, we have the subnets, route tables, internet gateways, elastic IPs, endpoints, NAT gateways, peering connections, security, under security, I have network access control lists, security groups, role groups, networks, firewalls, VPNs, and stuff. Now, the very first thing which you should understand as far as the VPC service on AWS is concerned is the VPC. So you can see all the VPCs in your region. Now, also to note that VPCs are region specific. So you can create a VPC, or when creating a VPC, you must specify which region that VPC is. VPC created in one region will not be found in another region. So if you create a VPC in Ohio or in North Virginia or in North California or in Oregon, all the resources that are found in this VPC will remain only in the region in which the VPC or the resources were created in. Now, to note that there is no service or there are no resources that you can create on AWS Cloud without actually specifying the network which they belong in. So all the resources which you are going to be creating, you must specify what network they belong to, and that is done using the VPCs. So VPCs actually are the ways where we put all our resources. Now to see all the VPCs in your various in your environment, once you're on the AWS dashboard, you click on VPCs and you see all the VPCs. You can actually create a VPC by creating the VPC here. You can view the details of the VPC, the VPC ID, if the VPC is available. You can also view if the VPC has been made a default VPC or it's not the default VPC. And as far as VPC is concerned, you should also understand the CIDRs. I talk about CIDRs. CIDRs basically are the addresses, and you can even get a little bit of information. Amazon supports IPv4 and IPv6 addressing and has different CIDR block size code for each. Now, the CIDR blocks basically are the ways which you can partition these VPCs together. Now, as far as CIDRs are concerned, the VPC CIDR here gives you the CIDR or the address range in which the VPC is operating. Now, for you to view who has accessed resources in your VPC into and out of the VPC, you can do that using what we call the flow log. So for you to view traffic into and traffic out of the network, you can do that using the VPC flow log. And for you to create it, you can actually create a flow log tracking how data gets into and out of your VPC. Now you also have other VPC configurations. Once you have a VPC, you can have the VPC name, the VPC ID, the state, the IPv4 CIDR, IPv6. That's basically the Internet Protocol version. IPv4 CIDR and IPv6. You can see the route table which that VPC has. You can see the VPC network access control list. You can see if it's a default. You can see the tenancy. You can see if it's default, and then you can see the owner ID, which user actually has the VPC. So that's the first thing about VPCs. As far as VPCs are concerned, we also have subnets. Now, subnets basically, like mentioned, are subcategories of your main VPC. So once you come to the AWS console, you see all the available subnets, the name of the subnet ID, the state, the VPC to which that subnet belongs, the CIDR range of that VPC, the available IP addresses. Remember, we say VPC subnets are a sub-partition, and when you partition a VPC into subnet, it means that you want to give a given number of IP address ranges to that subnet. So the VPC subnet or the available IP addresses is kind of like the subnet. So the subnets basically will partition the VPC into available IP addresses which you can partition to your resources. Now, VPCs are found in what we call availability zones. Once you did the cloud basics, you should have understood what availability zones are. And with that, we have a VPC availability zone and other subnet. We have the subnet availability zone. Now, if the subnet is attached to a particular route table, you see the route table to which the subnet is attached to, and then you can see if the subnet is a public subnet or a private subnet. And now also, if you create a resource and you want that subnet to give that resource a public IP automatically, You can do that using the auto assign public IP address to a resource. So these are some basic subnet configurations. Now, once you click on a particular subnet, let's click on this public subnet. You will see the details of this subnet. You can also view the subnet flow logs, how traffic got into and out of that subnet. You can view the route table to which this subnet is attached to, and then you can also view the network access control list, how traffic is ranged, how traffic gets into the network or into the subnet and out of the subnet through the inbound and the outbound rules. And then also you can see CIDR reservations. You specify some particular CIDRs to use, how you can share this subnet, and then lastly the tags if you want to tag this subnet. So these are the key configurations as far as a subnet is concerned, and we can have a public subnet or we can have a private subnet. Now we also have route tables. Route tables basically enable you to be able to route traffic. Now once you have a route table, you have the name, the route table ID, the explicit association. You can associate the route table to a subnet. We also have the VPC to which the route table might be attached. So let's take this one route table for example. If you see the route table details, the route table ID, the associations and all that, and then the route is one of the most important things. The routes basically specify how the route table routes traffic, or like you mentioned, the routes basically specify which traffic is allowed into and out of the network and how do they pass. So if you see, like we have here, we have the destination. We want to route traffic to this address, which is the internet, and we are passing it through the internet gateway, and it's showing that it is target that is active. So that's one of the key things you understand the routes. Now, as far as VPC is also concerned, we have the internet gateways. The internet gateways, like I mentioned, is what enables you to make a subnet public. You can also read information about the particular service when you see the info here. It says an internet gateway is horizontally scaled, redundant, and highly available VPC component that enables communication between your VPC and the internet. So the internet gateway gives you possibility to connect your resources to the internet. And once you have your VPC internet gateway, you connect this internet gateway or attach this internet gateway to a VPC. So if you click on this internet gateway, they tell you this internet gateway is attached to a VPC. Now we also have NAT gateways, another very important concept. The NAT gateways basically, they are the resources that can make a private subnet public. So if you want to get a little bit of information about the NAT gateways, you click on info. So you can use a network address translator gateway to enable instances in a private subnet to connect to services outside your VPC, but prevent such external services from initiating connection with your instances. So basically the private subnet will enable that you resources within your subnet can communicate to the internet, but no one from the internet can come into your network because of the NAT gateway. Now we also have some key security services which you should understand. We have the network access control list, which helps you to specify certain guides of traffic into the network at the network level and out of the network at the network level. And the network access control list has basically two roles: the allow role and the deny role. So let's take this network access control list for example. You get the details, and then you can see the inbound rules. For rule number 100, all traffic that is coming to port, or that is coming to port 000, let's allow. And then for the other one, all traffic that is coming to port 000, let's deny. Now the inbound rules basically are the ways through which you can configure traffic into and out of the network with the network access control list. And then we also have the security groups, and security groups helps us to actually create what we call firewalls. So the security group is like the firewall to prevent unauthorized access to in so the security group are the components which we use to prevent on, or are the firewall service that we use to prevent unauthorized access to our resources in the cloud. So assuming you have a EC2 instances and you want to prevent unauthorized access to that, you can do that using the security groups. So if you click on that, you get the details, the security group details, the inbound rules, the outbound rules, and the tags, just like the network access control list. So these are the key services which you must understand as far as VPC is concerned. You can go on ahead to look at other services like peering connection. You can also look at another service like transit gateways, but those are the key services which you must have a good working understanding of. The first task is for us to create a VPC with two subnets, one public and one private. So for us to do that, you click on create VPC. Once you click on create VPC, you can go ahead to create VPC alone, or you can create VPC and more. For this first task, we are going to use VPC and more. And for us to do this, you give the name of the VPC. By default, if you select this, it will give you a suggested name, but we are going to give it a name. Give it Wanda. Once you give it the name Wanda, it's automatically going to add the VPC to it. Now, once you have this, you can allow the default public IP CIDR if you want to change, but this CIDR gives us 65,536 IP addresses. You can actually enable IPv6 CIDRs, and then you also have to allow the configurations as default. Now, the exercise says you create with two subnets, one public and one private. Once you're creating, you can select the availability zones in which the subnets will be found. So you can select if the subnet should be in one availability zone. If you select one availability zone, you'll see that we have all our resources will be created in the US West 2A availability zone. Now, if you also come and you select two availability zones, our resources will be created in the US West 2A, US West 2B. Remember, the US West is with respect to our region. Our region is currently in the US West 2 region. If you are in another region, you will see the resources based on your own region. If you want to create your resources in three different availability zones, you select three different availability zones. But in this exercise, we are going to use just one availability zone. As far as the subnets are concerned, the exercise says you create one public subnet and one private subnet. So for you to create a public subnet, you can actually specify if you don't want any public subnet or if you want a public subnet. So if I select one, it's going to create this VPC with one public subnet. You can see here we have subnet, Wanda subnet, public one, US West 2A, and it has a route table that is attached to it, and then it's attached to an internet gateway. Now, you also have the possibility to create a private subnet. So you can select, do you want no private subnet? If you select no private subnet, if you come here, you will see that it's just creating a VPC with just the public subnet. But if you specify that you want one private subnet, is going to select the VPC, the public subnet, and then the private subnet. If you want two private subnets, it's going to specify the public subnet and two private subnets. So it's all based on your configuration. So we are going to allow it to one private subnet, and then now we allow no internet gateway because we are not yet configuring the internet gateway. We allow the default S3 gateway that can be used for access. Like if you want to access the VPC without you necessarily having a NAT gateway, you can use a VPC endpoint. Once you put up these configurations, you come to the preview, you see the name of the VPC, the public subnet, the private subnet, and then you see the route tables, Wanda route table public, Wanda route table private, and then you can go ahead to create the VPC. So you click on create VPC. Now, once you see create VPC, we have create VPC, VPC CIDR this. We have the enable DNS, VPC verifying creation, create S3 endpoint, and so on. So it creates all these resources and it gives their various tags. So once that is done, you click on view VPC and you'll see the VPC that has been created. We have Wanda VPC with the tenancy as default, and then we have now the CIDR which is specified. And if you come to the resource map, we see the VPC. You see it has two subnets, Wanda subnet public one and Wanda subnet private one. And you can also see the respective route tables that are attached to this subnet, and you can see other network connections. So this is basically you doing the first task where we've created a VPC, Wanda VPC, and then we have subnets, one public and one private attached to the subnet. We'll go ahead to delete this VPC to continue with the other steps in this exercise. So for you to delete the VPC, you select the VPC, you come to actions, and then you take delete VPC. Once you take delete VPC, if there's any resource that is currently using the VPC, that will be indicated. Like in this case, they tell us we have these resources and they will be deleted with the VPC. So you see the following six resources will also be deleted permanently and cannot be recovered later. So for you to delete, you just type delete and then you take delete. It's going to delete all those resources, the endpoints, the internet gateways, the subnets, the route tables, the VPC, and the endpoints. Everything will be deleted, and then you successfully deleted VPC, Wanda VPC, and six other resources. So that is it for the first task. The second task is for us to create a VPC, one public subnet and one private subnet attached to the VPC. So for us to do this, you see, come back to VPCs, you click create VPC. Now we are not using the VPC anymore. We select VPC only. We give it the name Wanda VPC, and then we give it a CIDR block 10.0.0.0/16, and then we allow the tenancy as default. We allow the tags. It already has tags name Wanda VPC, and then you click on create VPC. Now the VPC has been created. You successfully created VPC Wanda VPC. You see, it has just the route table, a default route table that is attached to this VPC. But we are going to create our own, one public subnet and one private subnet, and attach it to this VPC as stated. So let's go to subnet. We click on subnet. We click on create subnet. We select the VPC which we created, Wanda VPC. We give the subnet name Wanda public subnet, and then you specify the CIDR of the subnet. It must be within the VPC CIDR. So for us to do that, we give it a CIDR 10.0.0.0/24. You can create 256 IPs with this CIDR. You allow the tags as they are, name, Wanda public subnet name, and then you click on create subnet. So this will create a subnet with the name Wanda public subnet. Now let's go ahead to create the private subnet. So we do the same thing, create subnet. We select our VPC, Wanda VPC. We select the name Wanda private subnet, and then we give it its own CIDR 10.0.1.0/24. You see, this also has the possibility of having 256 IPs. You allow the tags name Wanda private subnet, and then you create subnet. So once you click that, you see we have both subnets, Wanda public. So if you cancel this, you will see in our environment now we have Wanda private subnet and Wanda public subnet, and all these subnets, they are all found in the Wanda VPC. The next task is for us to create a custom route table for the public subnet and associate it with the subnet, with a public subnet to control traffic between subnets. We come to route tables, we create route table, we give it the name Wanda public route table, and then you select the VPC. You want it in the Wanda VPC, and then you allow the tag. So you create the route table. Now we want to associate this route table to the public subnet. So for us to do that, we click on subnet associations, and then we edit subnet associations, and you see we have two subnets, the Wanda public subnet and the Wanda private subnet. So because it's a public subnet, we attach it to the public subnet table, and then we save associations. We now have a successfully updated subnet association for the route table Wanda public route table. We do the same thing. We go back to route tables. We create the route table for the private route table. We say Wanda private route table, and then you see select the VPC, Wanda VPC. You allow the tags, and then you create route table. Once the Wanda private route table has been created, you see come to subnet associations. You edit subnet associations, and then you select the Wanda private subnet, and then you save those associations. So the Wanda private subnet has been attached to the Wanda private route table. The next task is for us to create an internet gateway and attach it to the public subnet and allow a route to the internet through that internet gateway. So for us to do that, we come to internet gateways, we click on internet gateway, we create internet gateway, we give it the name Wanda internet gateway, and then you create the internet gateway. By default, when you create the internet gateway, it is detached because it is not attached to any VPC yet. So for you to attach this internet gateway to any VPC, you select the actions, you take attach to VPC, you search the VPC, Wanda VPC, and then you take attach internet gateway. And once you do that, you change the state to attach, and then you see the VPC to which it is attached. Now, for us to edit a route to the internet using this internet gateway, we come back to route tables. We come to our public route table, our under public route table. We go to subnet associations just to confirm that it's associated to the public subnet. And then we come to routes. Once you're on route, you see there's a route to the VPC using our local target. For us to add a route to the internet using the internet gateway, we click on edit routes. Once you click on edit route, you take add route, you give the route to the internet 0.0.0.0/0. You specify the target as the internet gateway, and then you specify the internet gateway in your environment. So you have the Wanda internet gateway. You just select this and then you click save settings. Once you save the settings, you see updated route for route table Wanda this successfully. So it now means that we can access resources in the internet using our internet gateway. For us to do the same thing, for the private subnet, we need to create a NAT gateway. The next step is for us to set up a NAT gateway in the public subnet to allow inbound connectivity for resources in the private subnet. So we come to our NAT gateway, you click on NAT gateway. Once you click on NAT gateway, you click on create NAT gateway. Now you give the name of the NAT gateway, Wanda NAT gateway. It says select a subnet in which you want to create the NAT gateway. So we are going to create this NAT gateway in the public subnet. So we come to Wanda public subnet. We create the NAT gateway in the public subnet because there is already a route in the public subnet for internet access using the internet gateway. So once you select the public subnet, you allow the connectivity type to public, and for it to be public, you must allocate an elastic IP, which is a fixed IP. So for you to allocate that elastic IP, you click on allocate elastic IP, and an elastic IP address this has been created. Always make sure to delete this because an elastic IP is one of the services that are actually built. So once you select all of these, you click on create NAT gateway, and once your create NAT gateway is completed, you can now go to your private route table and create the route to the internet using the NAT gateway. So for us to do that, you click on route tables again. You come to our private route table. You come to routes. We have a route to the VPC using our target local. So we have to edit the route. And then now we are creating a route to the internet. We are creating a route to the internet, this time making use of a NAT gateway, no longer the internet gateway. So we use NAT gateway, and then we specify the gateway which you just created, the Wanda NAT gateway, and then you take save settings. Once you do that, we now have a destination to the internet using the NAT gateway, and you find it active. The next task is for us to configure a security group to allow inbound traffic and outbound traffic for instances both in the public and private subnet. So for you to do that, you come to security groups here. You come down to security and then you click on security groups. Once you click on security groups, you can go ahead to create security group. You give it the name. You give it the name Wanda security group, and they say maybe this group we want to allow SSH for SSH access to our developers. So let's say allow SSH access for developers. Now you have to select the VPC that the security group we found in. So you click on VPC, you select the Wanda VPC, and then now inbound rules, basically you are specifying how traffic is getting into the resources behind the security group. So for you to allow inbound traffic or traffic that is coming in, you need to specify inbound rules. And for you to specify inbound rules, we come to add rule. If you want to allow a particular traffic type or from a particular IP address, you select that in the traffic type. So for you to do that, you click on custom ITCP, and then you can select your traffic based on the traffic that you want to receive into your environment. So for this case, we want to allow SSH traffic. So you take SSH traffic, and then once you select that, it automatically gives you the protocol on which SSH is working and the default port which SSH uses. So the next thing is for you to configure the source. Where is this traffic going? And for you to configure that source, you select, do you want the traffic to go custom or to anywhere IPv4, or do you want the traffic from anywhere IPv4 or anywhere from IPv6 or from your computer? So in this case, we take anywhere IPv4 and then you specify the direct IP for IPv4. So by this, we have added an inbound rule that allows traffic on port 22 to our environment. And now security groups actually want to create an inbound rule. You don't need to create an outbound rule because security groups are stateful. So once you do that, you click on create security group and you see security groups SG. This is one that security group was successfully created. And if you see the inbound rules, we have inbound rules SSH TCP port 22 from anywhere. And then you come to our outbound rules, you see outbound rules, all traffic, and that to the internet. So that basically is for us to configure the security group. Now, as far as security group is concerned, only traffic that you allow in will get into your network. So you should always take note of that. Only traffic that you allow in will get into your network. We also have network access control list, NACLs, which you can use to explicitly define traffic that comes into your network using deny and allow rules. So for you to do that, you click on create a network access control list. And once you click on create network access control list, you can give the name Wanda network, or you can just give it a short Wanda NACL, and then you select the VPC which this network access control list is found. We take that Wanda VPC and then you click on create network access control list. Once you click on create network access control list, this is the network access control list. Now, same as security groups, network access control lists allow traffic into and out of our network. But now the network access control list is at the network level, while the security group is at the instance or at the EC2 level. So for us to allow inbound rules, you come to inbound rules. By default, the network access control list denies all traffic that is coming into your network, and it also denies all traffic that is leaving your network. And for you to edit inbound rules or traffic that is getting into your network, you select edit inbound rules. The hashtag, the hash is the default rule. So for you to add a new rule, you take add a new rule, you give a roll number. The roll numbers basically are the order. So a roll number that is higher than the other will actually be the final result. So for us to execute this, we select a roll number. You can say 100, and then you select okay, custom TCP. You want to allow custom TCP or want to allow this still the same SSH on port 22. You give it a default port, and then now what is the rule that you want? Do you want to allow SSH into your network, or do you want to deny? Once you say allow, it's going to allow traffic, and once you say deny, it's going to deny traffic coming from the internet on port 22. And you can also get a little bit of information about this. So they say rule number info. Rules are evaluated starting with the lowest numbered rule, like I mentioned. So they will start implementing from 100. Assuming I was to add another rule, I'll come here, I'll put another rule 200, and then I'll say this rule is IPv4, and then you take allow. So by default, as soon as a rule matches traffic, it's applied regardless of any higher numbered rule that may contradict it. So once it comes, it starts implementing the lowest numbered rule. So if you have a rule that you want to implement the first, it will start by implementing this lower numbered rule. So once you have all of these, you take save. And once you take save, you now see that we have successfully updated inbound rules for the Wanda access control list. So you now see that 200 is higher. So it's going to implement the highest. It started implementing the lower. So it will deny all traffic on port 22. You allow all ICMP traffic. So that is basically how you configure NACLs. Once you configure inbound, you have to come back to outbound and configure the same configurations. So that is it for the network access control list and security groups. Also, as far as VPCs are concerned, you also want to check out the other services. We have customer gateways, virtual private gateways, and then we also have some important things, peering connections. Now, how do we create or how do we connect two VPCs Assume you have resources in one VPC that you want to communicate with resources in another VPC. How do we create that communication or that connection between those two VPCs? All that is done using pairing connections. And for you to create a pairing connection, you click on create pairing connection and you give it a name, Wanda connection. You select the VPCs. Which VPC are you actually going to be requesting resources from? So we can take our default VPC. Our default VPC is 172.31.0.0/16. So this VPC is going to be pairing. Pairing means you want to connect two VPCs together. So do you want to connect two VPCs within the same account or within another account or within accounts in different regions? So for you to do that, you select the VPC as you selected. You come under account. If the VPC was in another account, you can select another account and then you give the account ID. But if it's in the same account, you allow it on my account. And then for the region, you can specify the region on your AWS environment that you want to pair the VPC to. That is to say that a VPC in US West 1 can be paired with another VPC in US East 2. And once the two VPCs are paired, if you are in either of the regions, you can access resources found in either of those regions. So we allow the region as US West 2. You could also specify another region where you select the region based on AWS regions and then you do that. So let's allow this region, and then which VPC is going to be the acceptor VPC. Now, once you want to select a VPC that will be the acceptor VPC, you now come here and you select Wanda VPC. So by this, the requester VPC main is going to be making a pairing request to the acceptor VPC Wanda VPC. So once you do that, you click on create pairing connection, and now you see Wanda pairing connection. A VPC pairing connection PCX Wanda pairing has been created. You can actually see actions. Since we are in the same region, we can accept the request simply by coming to actions and then you select accept request. Because we're in the same region, US West 2, we can easily accept the request. But if you were in another region, you could come still to pairing connections here and then you see a request being made. So since we are here, we just accept the request. And once you click on accept the request, it now tells you that there is a pairing connection between the two VPCs. You see the connection is active. So you come back here to pairing connections and you select this. You see that the status of this connection is active. So this connection is active. You can get one or two details here. If I'm to edit traffic between the two VPCs, you come back to your route tables, you select the public route table, and then you come to routes, you click edit routes. So now we're going to add a new route. Maybe you want to route traffic from one VPC to the other. So in this case, we want to route traffic through the pairing connection. And for you to route traffic through the pairing connection, you must know both VPC siders. So our main VPC is on 172.31.dat. So we copy this cider range. Now, for us to allow traffic between the two VPCs, between the main VPC and the Wanda VPC, you come to route tables, you click on routes, and then you edit routes, you add a route. This route now is going to this route is no longer going to the internet or going to your default. This route is now going to the other VPC you did pairing with. So you select this and you now use what we call pairing connection. So instead of you using an internet gateway, it's going to route traffic to the other VPC using a pairing connection. And once you've already created a pairing connection, Wanda pairing connection, you select this pairing connection, and then by default, it's going to create now a new route. So you can take save settings, and you now say you can move to the VPC 172.31.0.0/16 using the pairing connection which we created. The last basic thing which you should know as far as VPC is concerned are transit gateways. Same as the pairing connection, transit gateways gives us the possibility to connect two or more VPCs. So if you have two or more VPCs, you want to connect them, you can do that using a transit gateway. You can actually set this up where you have the cider block across VPCs. So this is the last service which you can use to configure your transit gateway. And the transit gateway acts like a router between resources. So those are the basic services which you should know about VPCs, and that does it for our tasks. Let's go ahead to tear down our infrastructure. So for us to tear down the infrastructure, we start by the peering connection. We come to our peering connection. You select the one that peering connection. You take actions. You take delete peering connection. This peering connection has been connected in this route table. So one, before you delete it, you must be able, before you delete this peering connection, you must delete the route that you created. So let's delete the route which you created in a public route table. So you take delete. If you don't do that, you'll not be able to delete. So you select delete. Once you take delete, you now see that the pairing connection has been deleted, and you refresh. You no longer have that pairing connection. So you can see, click here, and then the pairing connection has been deleted. The next thing we need to delete is our NAT gateway. So you come to NAT gateways, you select the one that NAT gateway which you created. You come to actions, delete NAT gateway. For it to delete, you must delete the elastic IP. So you take delete, and then you click delete, and it's going to delete the NAT gateway. Once it's deleting the NAT gateway, you also have to come to elastic IPs to be sure you do not have any allocated elastic IPs. So once you click on elastic IPs, it's going to load any allocated IPs which you have. So you see we have this elastic IP and that elastic IP. So you have to make sure you delete all these elastic IPs. For you to delete that, you select the elastic IP, you come to actions, and then you take release elastic IP and release. You will no longer have the elastic IP attached to your account. You do the same thing, you come here, you take actions, you take release elastic IP. So it cannot be released because it is currently being deleted by the NAT gateway. So you have to give it a minute. You can still come back to NAT gateways. You check if the NAT gateway has been complete. You check if the NAT gateway has been completely deleted. So you can refresh here. So it has been completely deleted. You come back to elastic IPs. You take actions. You now take release elastic IP. Oh, it's probably attached to this elastic IP is probably attached to a different subnet. So let's cancel this. We now go to internet gateways. We select our Wanda internet gateway, and then we come to actions. We detach from a VPC. For you to delete it, you have to first detach it from a VPC, from this VPC. And after it has been detached from that VPC, you now select it, and then you take delete internet gateway, and you type delete, and that should delete the internet gateway. Once the internet gateway is deleted, you come to route tables. The same thing. The Wanda public route table. Before deleting the route tables, you have to come to subnet associations, and then you edit subnet associations. You remove the subnet associations, and then you save. Once you save that, you'll be able to delete the route table. So once you do that, you type delete, and you should be able to delete the route table. The same thing, you come to our private route table, edit subnet associations, edit associations, untick, save associations, and then you come back here and you delete route table. You type delete, and you should be able to delete route table. Once that is done, you come now to subnets. You start with the Wanda public subnet. You take actions, delete subnet, you type delete, and it should delete the subnet. You do the same thing. You come to the private subnet. You take actions, delete subnet, and it should delete the subnet. You come to our security groups which we created. You take security groups. You search for the Wanda security group which you created. So this is the Wanda security group which you created. Select the security group. You take actions, and then you delete security groups, and this should delete the security group. Once you do that, now the last thing is for you to come to your VPCs. You select your Wanda VPC, and then you delete the VPC. You type delete, and then you should be able to delete the VPC. So you're deleting the VPC with all the allocated resources. So that does it for our VPC module.